Okay, so on the Intro to Graphing Rational Functions packet that you guys have, I would like you to start this the same way we did yesterday. I would like you, I guess there aren't any points for you to plot, but I would like you to fill in the marks on your number line, including the marks on the top number line. Don't put the graph together yet, though, because we have to talk about how to deal with that extra piece of those asymptotes in there. Although, actually, I think you can handle drawing in the asymptotes. So draw in the vertical and horizontal asymptote. And did the row at the end with Kaylee in it get an extra copy of this one? Did I give you one before? I think I might have given you one before. I just need to make sure I have enough for the other class. Maybe possible. Yeah, I think I did give you one. I'm really not sure what you did. Sorry about that. Okay. So, vertical asymptote at x equals 3. And we should probably draw in the asymptotes with dashed lines because we don't know, not because we don't know, because they're not actually on the graph. They're just going to help us get the shape of the graph a little bit. Horizontal asymptote there. Let's see, this is not looking great. Well, okay, let's see. Decreasing, decreasing, concave down, concave up. I'm thinking shapes like those. Possibly? So here's the deal. The asymptotes are just additional pieces on the graph that my graph needs to get close to when I'm far left and far right for the horizontal ones or slant ones, and will get very close to vertically when there happen to be vertical asymptotes. They just kind of affect how the graph may be curved a little bit. I need to follow the shapes that I have, but also be guided by the asymptotes. I am going to start very close to the horizontal asymptote. Will I be like above the asymptote or below the asymptote initially? Below. Why are you saying that? You're right. Because of the shape that I have to take on. So I now need to be concave down decreasing, and then I need to curve until I get to my vertical asymptote. So I'm concave down decreasing until about there.
So it's not necessarily accurate, it's just some sketch.
Yeah, because we don't have any particular points here. We're just going for the basic shape. Then, should I start up high or down low after the asymptote? After the asymptote, yeah, I need to start up high because I need to be able to take on this sort of shape, which is going to be decreasing concave up. So I'm going to start up here, and I'm going to curve around. And again, I'm going to be guided by that horizontal asymptote and leveling out at the end. And that is what your first graph is going to look like, which is not the most exciting rational function, but that's the idea. I would like you to do everything but the graph in number 2. Fill in the number lines, get the points on there, get the asymptotes on there. I want to do the graph with you, though. Hello? Absolutely. Yep. Thanks. Bye. So I've got 2 different horizontal asymptotes. I'm allowed at most 2 different horizontal asymptotes. But when I'm far to the left, which one am I close to? Y equals 4 or y equals negative 4? How do I know that? Okay, the shape helps, but there's something else. The limit as I approach negative infinity, that's telling me what's happening to the left. So I'm going to start close to this one. I need to be concave up increasing until I get to the point. Then I need to be concave down increasing. And then again, there's another horizontal asymptote, so I'm just going to kind of level out like that. Have a good week. Maybe that's also not the most exciting graph. I thought number 3 was number 2. I want to see how far you can get in number 3. I want to see if you can do the whole thing. And then after this one, we'll get into the actual formulas. Hopefully we will have time to do 2 examples of this. Number 3. Ooh. Did I mess up with this? Look in the beginning. Does that anything look weird? Okay, you know what? Just go. See what happens. Maybe it's okay. Maybe it's a mistake.
We might be able to just ignore the word. Yes.
I would like you to put the points in there.
Gotcha.
Fill in the number lines. And try to deal with the way I had it. Maybe it was a mistake. Maybe it actually is correct that way somehow. We'll see.
Well, I bet it is correct.
I want you to try it. I don't know. It's been like a whole year since I did this packet. I don't remember if I messed up and just didn't correct it. How many times this year have we gotten to things where I said, oh, I was supposed to fix that last year and didn't? Just do the problem. We'll see. I don't know what's going to happen.
Sounds like he knows, guys.
Oh my gosh.
Hey, people in Disney, you hear that?
You are working, because again, I need to be able to get to 2 examples. Say that again. What's your question? Yes. Someone was asking about an asymptote. What were you asking about? Shouldn't be. I've got a vertical asymptote. Oh, okay. You're talking about the slant asymptotes. Okay. Well, here's the deal. The slant asymptotes are just talking about what's happening far to the left and far to the right. So it is perfectly okay to cross a horizontal asymptote in the middle of a problem, and same with the slant asymptotes in the middle of a problem. Just draw them in and see what happens. Yeah, so I think it's going to pass through the point of inflection. I think it's going to be okay, though.
Then on the bottom one? Yeah. Are you at negative 1 to 1? Are you at negative 1 to 1?
No, not yet, but you still do.
Let's see. Thanks, you want me?
Okay, so when you think you're set with the number lines, take a look at my top number line. And then see if you can put it together. Okay, I'm going to start close to the slant asymptote.
Oh, I definitely know this.
I then need to be concave down increasing until I get to this point. And I think I can kind of do that just by following my asymptote and curving around. Then I need to be concave down decreasing until I get to the vertical asymptote. So it's going to look like that initially.
Yes!
Next, should I start at the top or at the bottom after the vertical asymptote? Top, because I need to take on a concave up decreasing shape. So I'm going to start here, and I'm going to be concave up decreasing until I get to that point. Then I'm going to switch to concave down decreasing. Again, it is perfectly okay to cross horizontal or slant asymptotes within the middle of your graph. They only really talk about what's happening far to the left and far to the right. Next, I'm going to start after the vertical asymptote up high. I'm going to curve around and get down to this point, and then curve around like this. So it actually was okay that my minimum was higher than my maximum because they're relative minimums. This is the lowest point for this part of the graph, and this is the highest point for that part of the graph.
I don't understand why you are allowed to cross an asymptote.
Really by just the definition of these things. The definition of either a horizontal or a slant asymptote is what is going on far to the left, far to the right. What is the limit as x approaches infinity? That has nothing to do with what's happening at x equals 0, or 2, or 3. It has to do with what happens when x is a million, way far to the right, way far to the left. Vertical asymptotes work differently. But horizontal and slant, it's okay to cross them. Any questions on this? As I think you're seeing these graphs are a little more involved than yesterday. What we now need to do is deal with this from formulas. And I have two formulas I'd like to be able to get to. The first one we're going to look at. So in your notes, it's November 9th, section 3.6, curve sketching day 2. And we're going to take a look at the function f of x equals x over 4 minus x squared. The first thing I would like you to do is like what you did last night at the end of the homework. I would like you to find any vertical asymptotes and then decide, is there a horizontal or a slant asymptote, or maybe neither, and if so, find it, like you did at the end of the homework. The one behind you.
God dang it.
Where are the vertical asymptotes? Those aren't equations.
X equals 2 and x equals
Vertical asymptotes happen at whatever x values make the denominator 0, and don't also make the numerator 0, because then they'd be wholes. We're not going to deal with any of those. X equals 2, x equals negative 2. Is there a horizontal asymptote or a slant asymptote? Horizontal. Slant will happen when the degree of the numerator is greater than, well, 1 greater than the degree of the denominator. I don't have that here. So for the horizontal asymptotes, I need to do the limit as x approaches infinity of x over 4 minus x squared, which is like saying the limit as x approaches infinity of x over negative x squared. I can simplify that down to the limit as x approaches infinity of negative 1 over x, which is what?
0.
Will this be any different if I was approaching negative infinity? Then I'm not going to bother. I have one horizontal asymptote, which is the same on both sides, and it's y equals 0.
You want us to show the limits of each,
I do want to see the limit work. That's how you're getting the horizontal asymptotes.
even though we know if it's lower, if it's like x squared on the bottom.
But like, why does that rule work? Because of the limits. So yes. I'm basically now going to put these aside until the end of the problem. They're not going to affect my first derivative work, second derivative work, just when I go to do the graph. I would like you right now to find your first derivative. Do not move this up and use product rule, because then you'll have chain rule involved. It'll be more complicated than it needs to be. Use quotient rule. Go slow. Be careful with your positives and negatives, and see what you can do.
That's what I said.
Mm-hmm.
You said y equals 0 because it's 1 over negative 1 over.
Right, we're getting the limit as x approaches infinity of negative 1 over x. Plug in a huge number. That's close to 0. What do you mean? As long as that's still staying inside a square, though. This I think will be fine. You could also do maybe something like this, 2 minus x, 2 plus x, that entire thing getting squared. That's fine. What critical values are you getting from the top? Nothing. Plus or minus 2i, which doesn't matter. What are we getting from the denominator? 2 and negative 2. Okay. Number line, and please make sure you are labeling that number line as f prime. I'd like you to plug in. There actually is something in your derivative that I feel like makes the plugging in kind of nice. What am I talking about? Everything squared. So the denominator is always, actually, this is a square plus 4, which means the numerator is always. Plug in anything, what are you going to get? Okay. So no maxes, no mins. I'm not going to bother writing out increasing in the regions. We'll just take the information from the number line. So somehow this is increasing everywhere. The next part. This is going to be a little unpleasant. We need to do our second derivative. I am going to take this version of the first derivative, and I'm going to use quotient rule. And we're just going to be a little careful, because within the quotient rule, when you do d low, the derivative of the bottom, what are you going to have to use? Chain rule. Okay, let's do this together. Because actually there's two pieces of this. There's the calculus of getting all this, but then we've got to be able to simplify it, and the algebra gets a little messy. We've seen these tricks before, but we're going to have to be careful. Ari? Yes. All good? I want to keep that first derivative up there. Okay, here we go. Low is 4 minus x squared squared. D high is what? 2x. Minus high, x squared plus 4. D low, be super careful. What is it?
D low is
Perfect. Okay, draw the line. Square below, so the bottom is 4 minus x squared, squared, squared. So I'm just going to say 4 minus x squared to the fourth.
I'm having a blast.
Oh, good. Now, I'm going to kind of clean up the two pieces a little bit. I'm going to say f double prime of x equals 2x times 4 minus x squared squared. Let's see. How about I say minus plus? I'm going to say plus 4x times x squared plus 4 times 4 minus x squared. Still all over this thing. Here's the problem. Anytime we're doing derivatives, second derivatives of rational functions is going to get messy like this. The good news, though, is like the messy stuff that happens, it's always going to happen in the same sort of way. So our simplifying tricks are always going to be the same. What can you do up top? Jess? That is always going to be the trick. Look for a g. Actually, you know what? You can do a little better than that. 2x and 4 minus x squared. The trick is always going to be take out the GCF. Bless you. So I'm going to take out a 2x and a 4 minus x squared. I'm going to be left with 4 minus x squared to the first. Then what? A 2. I would like you to continue simplifying this. Basically, just deal with what's inside those brackets. Distribute and combine like terms. I see a little bit of canceling you can do. It should become kind of nice.
Don't spoil it for the rest of us.
All I really did was distribute the 2. Combine like terms, I'm getting x squared plus 12 inside. Notice, though, I canceled a 4 minus x squared from the top with 1 from the bottom to give me 4 minus x squared cubed. Nina, you look like you've got a question. You sure? Anyone?
Wait. Let me make sure I'm on the same step as you right now. Oh, you canceled the top.
I canceled a 4 minus x squared.
That's what I was gonna say. So you took that from, that's when you can cancel it.
Sure, because it is part of a product. You can cancel parts of products, not parts of sums. What do you get from the 2x for a possible point of inflection?
0.
0. How about the x squared plus 12?
Uh,
Nothing, imaginary number, so that doesn't count. What about from the bottom? Plus or minus 2. I would like you now to go make your f double prime number line and test your regions. It's not going to be as easy because we don't have the squares everywhere. Yes, things are going to change sign in different places. So do your number line for that.
So we can say possible point of inflections are x equals 1 plus minus 2.
Yes. Let's finish this problem and I'll explain the homework because we'll talk about that later. Yeah, we'll talk. I did something with the homework. We'll talk. Okay, how about you do your number line? Okay, then test your regions. You have your second derivative. What's your first sign?
Pause. Shoot. Positive? I got a positive. I got a positive region.
I am liking positive. Okay, so plug in -3. -3 squared is 9. 4 minus 9 is a negative. Cubed is a negative. The bottom is negative if you plug in -3. It's a cube on the bottom.
Oh my god, I said 4 plus.
Okay, so you're okay with the power. You're okay. When I plug in, there is a little thing I can save a little bit of time with. I don't have to plug in x squared plus 12 because that piece is always positive, so I can just focus on the rest. But your first piece will be a negative over a negative. It will be positive.
What's this stupid mistake?
Proceed.
So for these, do you want us to show the testing?
It might be very helpful to make sure you're getting the right signs. I don't have to see it, but I think your signs are going to be more right if you do. Plug in -1. It is negative.
I wasn't there yet either, man.
Plug in 1.
Wait. I plugged in -1, I got positive.
Okay. X equals -1. You're going to get 2 times -1 times...
I missed that.
Plug in 3. Positive. Positive. 4 minus 3 squared, 4 minus 9 is negative. A negative cubed is a negative.
Wait, positive on the third region, right?
Positive, negative, positive, negative.
Well, I'm trying to make sure that I understand.
Okay, enough. We now need to draw the graph of this thing. I'm going to draw a graph. I need tick marks that go out to 2 in one direction, -2 in the other direction. And let's see. I need some number lines underneath this. I need 3 stacked number lines. One for f prime, one for f double prime, and then the one on top should be for f. What directions?
I'm just labeling the number line.
F, F prime, F double prime.
Oh, gotcha. I understand.
So, on the F number line, which is what, everything that's on the.
Yes, you'll just kind of condense the 2 tick marks and then pick out which of the 4 basic shapes in each of the regions. Okay, turn around now.
No, you.
Yes.
This is my quiz.
I am aware.
Towards that way.
Think so. Dude, leave him alone. Yeah.
Yeah, that's my class. They're ganging up on me.
Yeah, it doesn't look like we're going to have time to get through that second example. In addition to what I have, I'm also going to go through and I'm going to put in the asymptotes. So I have a vertical asymptote at x equals 2 and another at x equals negative 2 from the original work. Well, right, but that's why we wrote that down, and we're going to need to do something with it. And I also have a horizontal asymptote at y equals 0, and I'm realizing that I actually forgot to do something. You guys realize why we didn't have any maxes or mins, right?
Yes.
Here's our number line. Do you see why there are no maxes or mins? Okay. Are there any points of inflection, though?
Possibly. Yeah.
Not possibly. I can look at this and know where they're going to be.
Yeah, there are.
There are points of inflection. At negative 2 comma something, 0 comma something, 2 comma something. Are they all, though, actually good?
I don't know yet.
I feel like I know that 2 of them are not going to be good.
Wait, how do you know? Isn't there something
Oh, the 2 and the negative 2 because they're on.
There are already asymptotes there.
That's, good thing we can Alright.
Go find the coordinates of that one point of inflection.
I put that into the report.
The original always gives you y coordinates.
Wait. You know they're not there because they're on.
If you tried to plug in, you would get negative 2 over 0.
Oh, okay.
Or we already know we have asymptotes there, so we can't possibly have a point of inflection there. 0, 0? I think so. That would be 0 over 4 minus 0 squared. Yep, 0, 0. So I'm going to add that point into my graph. Now, I'm going to put everything together and try to draw this.
Oh, I got you.
I'm going to start close to the horizontal asymptote. My first number line says I should be concave up increasing, so I'm going to curve around until I get to my my vertical asymptote, rather. And that's how it's going to start. Should I then start up high or down low? Low, so I can be concave down increasing. I'm going to start here, and I'm going to be concave down increasing until I get to the point of inflection.
So it just stops at this point.
Well, I'm going to stop there because I have more work to do afterwards. What am I doing after that point? Concave up increasing. So I'm going to curve around and become like this.
Wow,
Sort of.
that's amazing.
Then I'm going to start down here. And it's going to look like that. Yes?
So, I know you explained this when I said it, what's the point of having
No. So horizontal and slant asymptotes. Please listen because other people may have this question too. Horizontal and slant asymptotes are all about what's happening far at the ends. So I am getting close to that horizontal asymptote over here and close over here. That is all that it tells us. What's going on in the middle has nothing to do with the horizontal asymptote. We're perfectly allowed to cross it, that's fine. But far to the right I need to be close to it, and far to the left I need to be close to it. That's what's going on with those. Now, I do realize these problems take a while. Let me explain, though, about the homework that you'll get in a little bit, but I need to at least try to start one other problem. You are going to have 2 problems like what we just did. There are also going to be 3 other problems where I already calculated the first derivative and the second derivative for you. So your work's going to be just interpreting those derivatives and making your number lines to get everything else. It's still going to be some work, but at least you don't have to deal with the derivative stuff. Next thing, second example. Yeah, because I wasn't sure if you'd let me get through everything.
We're so prepared, Mr. Wixer. Mr. Wixer, that,
Next Wednesday during Thursday.
my mom already
Okay, I'd like to take a look at one more example.
you're one short over here.
I'd like to take a look at the example in front of you. We have the function f of x equals x squared minus 6x plus 12 over x minus 4. Where's the vertical asymptote?
X equals 4.
Because that makes the denominator 0. Why am I doing slant asymptote work on those papers?
Because the degree of the top is 1 greater than the degree of the bottom.
Okay, so I'm doing my division. I'm getting, remember the slant asymptote is the non-remainder. So y equals x minus 2 is the slant asymptote. Ignore the plus 4 over x minus 2.
Why don't you use it?
The whole point is this is what's going on when you're far to the left and far to the right. If you plug in a huge number, what is 4 over a huge number minus 2?
Just about 0.
That's why we can ignore that part.
Gotcha.
The other pieces, though, are not 0.
Oh, because it approaches infinity.
Right. So then I'm going to do my first derivative. I'm using quotient rule on this thing. We need to be extra careful with the signs and all that stuff. If you do it properly, though, it will give you x squared minus 8x plus 12. I'm talking through this right now, by the way. I would very highly recommend, though, that you actually try to do this problem before you start the homework so you have one other example that you've actually worked through. And as you're doing it, check things against my work to see, did I get down to this line? But I would very highly recommend you actually try this. I'm getting this for my first derivative. I then factored the top, got critical values at 6, 2. Oh, that's not right. There should be another one. Ooh, yeah, I guess I messed up. There should also be x equals 4. So we're going to add in x equals 4.
I guess this gives us reasons.
Although the signs will be negative on either side of that. I did my number line thing. I plugged in the regions. I saw there was a max over here, a min over here. Take a look through my second derivative work, and especially note the factor out the GCF part. Right now, the homework's coming out along with cumulative review number 9.
Wait, are they both negative?
Yes, they are both negative. Because the square in the bottom is going to make it not change sign.
You want us to pass some words up?
Hold on.
Hi, bad dog.
Yeah, hold on. Please pass up the rulers. I'm so glad I passed those out. By the way, we have one more day and we are done with this unit.
That means a test is coming.
That means the test is coming. The test is the Tuesday before Thanksgiving. No, it's not. The test is the Monday before Thanksgiving. Okay, we need to shut this off.